evaluate limit x tends to 0 sin x by x whole power 1 by x square. So here if we apply limit x tends to 0, so here limit sin x by x is nothing but 1 and the power we are getting 1 by 0, it is nothing but 1 by infinity. So here if we want to solve this one, so here first we consider this as k equal to limit x tends to 0 sin x dividing by x whole power 1 by x square. So here we have the power as variable. First we must remove the power. So to remove the power we apply the log both sides. Apply log both sides. So here log k equal to limit x tends to 0. So this is the form of log m power n. We can write it as log n log m. So here we get 1 dividing by x square into log of sin x dividing by x. So here if I apply limit x tends to 0, we get this is 1. So log 1 is 0 dividing by 0 format. So now we apply L'Hospital rule. So log k equal to limit x tends to 0. So here numerator we have log of sin x by x. So if we differentiate we get 1 dividing by sin x dividing by x. Then differentiation of sin x dividing by x, we must apply the quotient rule. We get x square. So we write x into differentiation of sin x is cos x minus sin x into differentiation of x is 1. Dividing by x square differentiation is 2x. So here we modify this one. Limit x tends to 0. So here we write it this as x cos x minus sin x. Dividing by this is 2x. Here x square is there. We get 2 times x cube. And this one we can write it as limit x tends to 0 x dividing by sin x. So this is nothing but 1. So here we have only this one, limit x tends to 0 x into cos x minus sin x dividing by 2 times x cube. So here if we apply 0 we get 0 by 0. So we apply L'Hospital rule. So left hand side we have log k. So here we apply the differentiation, numerator and denominator separately. X into cos x, we apply the product rule. X into cos is minus sin x plus x is 1 into cos x minus sin x is cos x dividing by 2x cube is nothing but 6 times x square. So here cos x get cancelled. So here if we write it this one, limit x tends to 0 minus x into sin x dividing by 6x square. So here 1x get cancelled. We write it 1 by 6 outside the limit. Limit x tends to 0. Sin x dividing by x. Sin x dividing by x. So this is nothing but 1. We get the answer minus 1 by 6. So here minus 1 by 6 is nothing but log k. Log k is minus 1 by 6. K can be written as e power minus 1 by 6. So this is the answer for the question. Limit x tends to 0. Sin x by x whole power 1 by x square. Evaluate. Limit x tends to 0. A power x plus b power x plus c power x dividing by 3 whole power 1 by x. So here we apply the, consider this as k. Limit x tends to 0. A power x plus b power x plus c power x dividing by 3 whole power 1 by x. Now we take the log both sides. Log k equal to limit x tends to 0. So here we get this as 1 by x into log of a power x plus b power x plus c power x dividing by 3. So this is nothing but numerator. Denominator we have the x. So here if we apply 0 here, we get log 3 dividing by 3 dividing by 0, 0 by 0 format. So here apply L'Hospital rule. So left hand side log k is there. Limit x tends to 0. Log can be written as 1 dividing by differentiation of log 1 dividing by a power x plus b power x plus c power x dividing by 3. Now we differentiate a power x plus b power x plus c power x. So 1 by 3 is constant. A power x is a power x into log a plus b power x is b power x into log b plus c power x into log c. And here denominator x is there, so x if we differentiate we get 1. Now we can cancel these 3. Now we apply 0 here. If we apply 0, a power 0 into log a plus b power 0 into log b plus c power 0 into log c dividing by a power 0 plus b power 0 plus c power 0. So here we get log a plus log b plus log c dividing by, this is 1 plus 1 plus 1, and here this is the form of log m plus log n plus log o. So we can write it this as log of a into b into c dividing by 3. This is nothing but 1 by 3. Can write it as log of a into b into c power 1 by 3, which is nothing but equal to log k. So here if we compare this one, we can write it as k equal to abc whole power 1 by 3 is the answer. Limit x tends to infinity is there. Pi by 2 minus tan inverse of x whole power 1 by x. So here first we write it this as k equal to limit x tends to infinity, pi by 2 minus tan inverse of x is there. It can be written as cot inverse of x power 1 by x. So here if we apply 0, we get tan inverse of 0 is 0. So this is nothing but 1 by 0 is infinity power, here small difference, limit x tends to 0 is there. We modify this one. So here if we modify this one, we get the answer. Otherwise here we must write it as power is 1 by infinity is there. It is nothing but 0. And this one cot inverse of infinity, tan inverse of infinity is pi by 2. Cot inverse of x is cos infinity is 0. Reciprocal of that one. This is the form of 0 power 0. So what we do? We do the small modification of this one. Limit x tends to infinity. This one we can write it as tan inverse of 1 by x whole power 1 by x. So here we have 1 by x, power also 1 by x is there. We consider let t equal to 1 by x. So it is nothing but x is infinity, t becomes 0. X is infinity, t is tends to 0. So here we can write it this as limit t tends to 0, tan inverse of t whole power t. So here we get 0 power 0 once again. What we do? We take log both sides. We must eliminate the power. So first we must write it this as f of x by gx. So we take log both sides. So that left hand side we get log k equal to limit t tends to 0. This one we can write it as t into log tan inverse of t. So as we know that log m power n is nothing but n into log m. Now this is the form of t into log of tan inverse. So we do not have f of x by g of x. So we do modify this one. We write it this as limit t tends to 0. So log we write it as it is, tan inverse of t, and this t we write it as 1 by t in the denominator. So if we apply this one, we get 0. If I apply 0, log tan inverse of 0. Tan inverse of 0 is 0. 1 by 0. So here we get minus infinity by infinity. Now apply L'Hospital rule. So log k in the left hand side, limit t tends to 0. So here log differentiation is 1 dividing by tan inverse of t. The tan inverse of t is 1 dividing by 1 plus t square. And here 1 by t is there in the denominator. We get minus 1 by t square. So we do the small modification here. We must have f of x by x g of x. So here we do the reciprocal. We get minus t square dividing by 1 plus t square into tan inverse of t. So here if we apply 0, we get 0 by 0. tan inverse of 0 is 0, so we get 0 by 0. Now apply L hospital rule once again. So log t equal to limit t tends to 0. So here we get minus 2t differentiation of t square. Here we must apply the product rule. 1 plus t square, we write it as it is. Tan inverse is nothing but 1 by 1 plus t square. So here differentiation of t is 1 plus 1 plus t square. 1 is 0, t square is 2t into tan inverse of t. So here we can cancel this one. 1 plus t square, 1 plus t square. We get limit t tends to 0 minus 2t dividing by 1 plus 2t into tan inverse of t. So here if we substitute 0, numerator is 0 dividing by 1 plus, here 0 is there, if we apply 0 we get 0. So 0 by 1 is 0. 0 by 1 is 0. Left hand side log t is there. T is nothing but e power 0. Log t equal to 0. T is e power 0. We get 1. So here we have k. So this is log k. So k equal to e power 0. E power 0 is 1. K equal to e power 0. E power 0 is 1.